Hey, what's up, guys? It's Mr. Selby here. I'm hoping to do a little bit of lesson part two with you guys for 2.8, proving angle relationships. So hopefully you enjoy this. um, like I said on part one, the point of these lessons, the objective here is for you to kind of understand how to prove things, how to use reason to show what you're thinking, all right, and prove your point. In addition, angle relationships are important so you can see patterns. This is good practice for a lot of things. I was thinking about the other day is even when you look through data and stuff, it's great to be able to see patterns, and this just works on that a little bit. Okay, so let's get going with it. We're going to review a little bit of stuff we did yesterday, and then in addition, we're also going to do some new stuff, which is always fun. All right, so we did that yesterday. Okay, protractor postulate, went over it already. Angle addition postulate, the really big stuff here. Add one section of an angle plus another section of an angle equals the whole angle. Boom. Already did that. We already know it's 48. Already know that's 104. Work that out. Supplement theorem, you add two angles form a linear pair. They add up to equal 180. Complement theorem, two angles add up to equal a right angle. They must add up to equal 90. All right. I already figured this one out with 60 degrees each. Don't forget a bisector cuts an angle bisector cuts an angle in half perfectly. Both halves are equal. Already did that. We already figured out that it was 50. And this is actually, I believe, where we left off yesterday. All right. So let's jump right back in with 2 feet. And we're going to learn about properties of angle congruence today. So reflexive property of congruence. Remember, reflexive, I've kind of said this before, reflexive is the same thing as reflection. All right. It's like looking in a mirror. One angle here, angle one is here, angle one is here. You know, they're both equal. Angle one is equal to angle one. One Mr. Selby is equal to one Mr. Selby. You know what I mean? Symmetric property of congruence. Angle one is equal to angle two, so angle two is equal to angle one. All right, that's like saying I have 5 eggs in basket A, and I have 5 eggs in basket B. So basket A is equal to basket B, and that's like saying basket B is also equal to basket A. I mean, you probably know it. So transitive property, so that's like saying basket A and basket B have the same amount of eggs, and basket B has the same amount of eggs as basket C. So that must mean that basket C has the same amount of eggs as basket A, which we could probably guess, right? All right. So symmetric property of congruence. Given angle A is congruent to angle B, prove angle B is angle A is congruent to angle A. I mean, we know they're going to be equal. If this is equal to this, this is also going to be equal to this. It'd be impossible for not, you know? Sorry, cracks me up a little bit. Symmetric property of congruence. Geometry jokes, am I right? All right, congruent supplements theorem. Angles supplementary to the same angle or to congruent angles are congruent, okay? All right, so congruent supplements theorem. So let's just say angle one and angle two are supplementary angles, right? That must mean that angle two and angle three are also supplementary angles. 1 and 3 are equal, right? Name any angle that angle two could be that's less than 180. And as long as it adds up to equal the same thing as angle one, as does angle three, angle one and angle three are going to be the same. Let's just say angle two is 50 degrees, right? Say it's 50 degrees. Angle one would have to be 130 degrees for them to be supplementary. Angle three would have to be 150 degrees for them to be supplementary. So they're both 150 or 130. They're both 130. They're equal. Congruent supplements there. Same thing with complements, except now it's 90 degrees. So if these are complementary and these are complementary, these two, 4 and 6, are equal. All right. Okay. Angle 1 and angle 2 are supplementary. Angle 2 and angle 3 are supplementary. Prove angle 1 and angle 3 are congruent. So this just goes to show how you can prove it. So if angle 1 and angle 2 are supplementary and angle 2 and angle 3 are supplementary, angle 1 plus angle 2 equals 180. Angle 2 plus angle 3 equals 180. Okay, substitution. So we just substitute in since they both equal 180. This equals this. Subtract angle 2 from both sides. You get angle 1 and angle 3. Angle 1 equals angle 3. All right, in the figure, angle 1 and angle form a linear pair. Hold the phone. You guys know what that means. Angle 1 and angle 4 are supplementary. Okay. Angle 3 and angle 1 are 180. You know what that means? Angle 3 and angle 1 are supplementary. You know what that means? Angle 3 and angle 4 are both supplementary with angle 1. And what does this say? Angle supplementary to the same angle or two congruent angles are congruent. Something tells me they're congruent. Let's prove it. Given angle 1 and angle 4 form a linear pair. Measure of angle 3 and then plus a measure of angle 1 equals 180. Prove. You can't read it. Angle 3 is congruent to angle 4. Let's prove it. Proof. Statements. Reasons. Statement 1. I just pressed the button 1. I thought it was going to be like a bullet thing where it like went 1 and then went 1 and then went 2 and then went 2 and then went 3 and then went 3. It wasn't like that. They did it all at once. I feel like that kind of like gets rid of a lot of the anticipation that you could have built there. So that's a bummer. Maybe I'll change that for next year. Because I felt like that would have been a lot cooler if we did one at a time. But we'll move on. So we're given the same stuff we're given. 3 plus 1 is 180. 1 and 4 also 180. 1 and 4 are supplementary. 1 and 3 are supplementary. Therefore, angle 3 and angle 4 are congruent, right? Because angles supplementary to the same angle are congruent. Boom. Yes. Okay. Check your progress. In the figure, NYR, NYR, and RYA form a linear pair. Hold the phone. That means they are supplementary. AXY, 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 and AXZ form a linear pair. Hold the phone. That means they're supplementary. And RYA and AXZ. Where's AXZ? AXZ. Wait. RYA, and AXZ are congruent. Prove that angles NYR and AXY are congruent. Oh my goodness. Oh my goodness. Let's see. Which choice correctly completes the proof? Wow. So we're given NYR and RYA and AXY and AXZ form linear pairs. NYR and RYA are supplementary. Okay. AXY and AXZ are supplementary, right? We're also given that RYA is congruent to AXZ. But what are we missing? What are we missing? Let's find out. Why don't you guys take a second? I'm going to stop speaking for about 5 to 10. It'd be great if you guys could pause the video, look at it, study it, break out the notes. I don't know, use your inner Einstein, figure it out, and then unpause it and stuff. And I'll just double check to make sure that you were right. I'm sure you're right. I'm sure everybody's got it. If you need to, when you pause it, feel free to go back on the video and relook at the past 2 screens. All right. So. All right, let's check it out. Were you right? You were right if you said C. Angles supplementary to the same angle or 2 congruent angles are congruent. Okay. Vertical angles theorem. If 2 angles are vertical angles, then they are congruent. I feel like we did this one earlier, but we'll go forward with it. So remember, vertical angles are the ones that are crossing each other, 1 and 3 here, 2 and 4. That means that they're also congruent. All right. If angle 1 and 2 are vertical angles, just to let you know that means they're equal. Measure of angle 1 is d minus 32. Measure of angle 2 equals 175 minus 2d. Why would anybody ever write it like that? I have no idea. Find the measure of angle 1 and measure of angle 2 just by each step. You want to know what's crazy? You only need to find the measure of one of them because they're the same thing. They're vertical angles. So what you need to do here, this measure of angle 1 is the same thing as the measure of angle 2. So you set them equal to each other. So measure of angle 1 equals measure of angle 2, or d minus 32 equals 175 minus 2d. Let's see how this thingamajig did, and it decided to go via proof. So vertical angles theorem, definition of congruent angles, substitution, because look, you sub in Instead of writing angle 1, you sub in d minus 32 because they're the same thing. And instead of writing measure of angle 2, you sub in 175 minus 2d because they're the same thing. Let's keep going. Oh my goodness, addition property. Who was ready for that? Look at that. They add stuff. They added 2d to both sides, it looks like. Yep. What will they do next? Something tells me more addition. More addition, double the addition. They added 32 to both sides. Very nice. 3d equals 207. And then division. They divided both sides by 3. You're going to get d equals 69. Speaking of 3D, has anybody been to one of those 3D movie theater shows? Are they good? Are they worth it? Are we ever going to be able to go back to movie theaters? I don't know. So many questions. And we're still in geometry. So measure of angle 1 equals d minus 32. And measure of angle 2 equals 175 minus 2d. We know that d equals 69, so we can sub that in here and make it 69 minus 32, and we could get 37. And we would also know, since angle 1 and angle 2 are vertical, we would also know that this one would also be 37. I think that's the easiest way to do it. You could also sub in 2 times 69 here, and I think you would get 138. 175 minus 138 would probably give you 37. But let's double check. Oh, look. This way I thought was more fun. All right. Angle 1 and angle 2 are 37 degrees. Check your progress. All right. So if you guys could take a quick second and go through this one. I'm going to stop speaking for like 5 to 10 seconds. If you could pause it, figure out the answer, unpause it, have me tell you are right. You got the right answer. And then we can keep going. All right, you were right. Congratulations. Good job. That's correct. The answer was B. Fantastic work. Okay. So pretty much you can look at this and be like, there's no way it's A or D. First of all, it says that angle A and angle Z are vertical angles, right? Which means they equal the same thing. As you can see, angle A and angle Z here do not equal the same thing. So A is wrong. Angle D, or number D here, they don't equal the same thing. 52 and 38? Man, come on. Definitely not right. These two could be right. All right. So it's important that we double check on this. Let's see. Well, let me tell it to the left. Yes, here we go. Okay, so was there another problem I did? No, this one's the last one. Okay, so angle A equals angle Z. We know that, right? They're vertical angles. We know they equal each other. Angle A equals 3b minus 23. Angle Z equals 152 minus 4b. So now we use a little bit of substitution. We use the same problem, angle A equals angle Z, and we sub in 3b minus 23 for angle A, which is what it equals, and then we sub in 152 minus 4b for angle Z. So they equal each other. I like to get all my variables. Variables are the letters for you guys that don't know. I like to get all my variables to one side, and that's one of the first things I like to do. And I always try and move the smaller one. And you might be like, well, 4 is bigger than 3, Mr. Selby. Why would you move 4 then? Well, because that's a minus 4b, which makes it negative. And as you guys know, positives are actually larger than negatives. I think I'd rather have 3 baseballs than have negative 4 baseballs. So what you do is I added 4b to both sides. Okay? These cancel out. And this makes it 7b minus 23 equals 152. Now, I could have subtracted 3b from both sides, but that would have hit me with a negative over here. Like I would have had 152 minus 7b equals 23, equals negative 23. And I don't want to play with negatives. So I'm going to move this one over. I'm going to move a negative over. So that way I work in the positives. All right. And I do the same thing here. I move over 23, okay, because it's minus 23. And you better believe I'm going to be working with the positives. So I'm going to add 23 to both sides. I'm going to get 7b equals 175. All right. So now I'm left with 7b equals 175. I'm going to divide by 7 on both sides. B equals 25. Oh, yeah. So angle A equals 3b. So now we know what b equals, but we got to solve for angle. It doesn't ask us what b equals. This problem doesn't care what b equals unless you were a C. Then you got that one incorrect. It wants to know what angle A and angle Z are. So I take angle A, 3b minus 23, and I sub in 25 for b. So 3 times 25 minus 23. 75 minus 23 equals 52. Angle A equals 52. Angle A also equals angle Z. So that means angle Z equals 52. Boom. And just like that, mission accomplished. All right, I think this is the last slide. Perpendicular lines intersect to form 4 right angles. Okay, all right angles are congruent because they're all 90 degrees, right? Perpendicular lines form congruent adjacent angles because they're all congruent. Yep, they're all 90 degrees. If 2 angles are congruent and supplementary, then each angle is a right angle. So 5 and 6 would be right angles because they're congruent, they're equal, and they're supplementary. All right. If 2 congruent angles form a linear pair, then they're right angles because the only number in the world that when you add it together by itself equals 180 is 90. So they got to be right angles. All right, a little bit of common sense stuff there. Just to let you know, if you go back through this video, which I always recommend that you rewatch Mr. Selby's video, not just because he's a fantastic voice and he works so hard on these geometry videos, and you really appreciate if you guys watch them a little bit more. I think one of my videos only had like 5 views the other day. That's not great. Okay, let's make sure we're all watching these. Peer pressure your friends into watching geometry videos. It's a great thing. Just to let you know, one of the best things to take notes on are all of these theorems. Okay, try and write down these theorems. Okay, I hope everybody's doing well. I hope everybody's staying happy, healthy, hydrated, and safe during these times. Remember, if you need anything, come to office hours, email me, message me on Schoology. All right, don't forget, I will be posting extra YouTube videos in case you don't like my videos, which would be weird. Why would anybody not like my videos? And like I said, these videos are on Schoology for hopefully the entire year. So if you ever like to, just feel free to rewatch them time and time again. Get those views up. All right. Hope everybody is doing well, and hopefully I will see you again soon. Ciao.